Hello everyone. Welcome to our ambient scientific tutorial where you will learn how to create your own custom wake word model using our software, EdgeSphere, and our custom toolchain via TensorFlow Keras. Please refer back to our previous videos to learn how to use EdgeSphere and easily collect your own data. After referring to that video, you will have collected your own wake word and non-wake word data samples, and you'll be ready to go. Once we have our datasets, you want to go into the Ambient Scientific folder in the C drive, go into Setup, Chip, FW, and Applications. In our previous EdgeSphere tutorial, we learned how to run our Alexa wake word model. Today, we're going to edit the word so instead of Alexa, it will be the keyword of your choice. If you go into the 12S Alexa folder, you will find a training toolchain. Double-click and go into the Python folder. You want to make sure that you create a dataset folder, which is not previously there. You will need to create it yourself using the New Folder feature. And in here, you want to create two folders called Wake Word and Not Wake Word. Once you have these, you want to fill up the first folder with your wake words, which for today, we will choose the custom word ambient, and our non-wake words, which can be any sound, word, or noise that isn't the ambient word. This can include other words, chatter, background noise, cars, audiobooks, or whatever sounds mimic your everyday environment. Now we can simply go into our file path and type in CMD. Once you enter your CMD, we want to make sure that we activate our environment, and then we type Python, and we can type in F, and then hit the tab button. We should see feature_feature.py. We can simply run this script, and it should take a few minutes, depending on your dataset size and processing power. In this case, we have 3,000 wake words and 3,000 non-wake words, so it should roughly take about 5 minutes.
Excellent! Our feature extraction is now complete. Now we can run the training toolchain script and we'll be halfway done. We can now type Python again in our CMD. We can type in W and hit Tab, and we can see our wake word model training.py. Again, this is the same name in your files to copy, but it's just a lot easier to type in Python, W, and Tab. We can now run this. Model training is in progress. Our training script is set to 10 epochs. If you want to edit the script in any way, you absolutely can by opening it in your own IDE and changing the number of epochs that you want, the number of layers that you want, and your architecture as a whole. Then you can come back to CMD and run the script. We'll let this run and come back in a few minutes. Excellent! Our model training is now complete, and we are ready to move on to the final step. Before we move on, please disregard any information regarding the TF Lite, as it is still in development and will be released in our next SDK very soon. We can minimize our terminal window, and we can go and see that we have a .h5 and a TF Lite model, as well as a confusion matrix of both models. We can delete the TF Lite model as well as its PNG. If you'd like to, we can look at the confusion matrix, and you can see that we have very good results with only 3 false positives in both the wake word and non-wake word categories. Great! What we'd like to do now is take this model, copy or cut it, and step back into our i2stm buffer folder and go into our test folder. In this test folder, we will see one word wake model. This is the wake word model that you received with your SDK. You want to replace this one, but you still want to keep the original safe for the future. So what we can do is go back into our training toolchain, into our Python folder, and we can rename our newly created model. Great! Now we can take our new model, copy or cut it, go into our i2s folder, proceed to our test folder, and paste the model here. Excellent!
Now we can go into the CMD, activate our environment, and open the CMDS text script in the test folder. In the text file, you will receive this top version right here. We can delete this from previous attempts. We can copy and paste this. And all you want to do is change this model name here. So we have new model.
You want to put an underscore for multiple words. We can save this. Make sure your UART is correctly adjusted to which port your DVK uses. If you're using Eclipse for debugging, you don't have to worry about the UART just yet, only if you are testing via CMD. We are testing in Eclipse today. Go back to here. Make sure that our model name does have an underscore. Great. In our CMD window, now that we're connected to our environment and ready to compile our model, please make sure that your DVK is plugged in via both the JTAG and micro USB. Once you've done that, we can copy and paste our script command. It looks like this. And we can see here that we have our new model name properly showing. We can click Enter and allow the compilation to occur. Within about 1 to 2 minutes, the compilation should be complete, and we are on the way to load it onto our GPX-10. Great! Your model has built successfully, and you can ignore the warning about the J-link down below. This warning will always happen, so it's nothing to worry about as long as your build is successful and the ELF has been successfully generated. You are all set to go to our last and final step, which is loading the model and testing out our new keyword. So, what you would like to do is open up Eclipse. Following the EdgeSphere tutorial last time, it will show you how to load the I2S project as well as setting up the debugger. Once that's completed, you can simply right-click the project, hit Refresh, hit Clean, and hit Build. Since you compiled the project in our terminal in our last step, the I2S project is now updated with this new wake word. If you want to go back to your previous wake word, you can simply type in the same script, but change the name from New Model to your wake word model. This will ensure that your latest model that you want compiled is running. Great!
Referring back to Eclipse, we'll see that we have 0 errors after our build. We can hit our debug button. Refreshing our memories, we can see that if we go into Debug As and Debug Configurations, you can see that the directory is pointing to the I2S project. We can hit Browse and follow this path, go into our debug, and find our ELF here. If you get tripped up, you can refer back to our previous EdgeSphere tutorial where it's explained thoroughly. Now we can hit the debug button. We can hit our Open Terminal command here and hit OK, making sure that all the serial output settings are appropriate. Our DVK is plugged in. It's all ready to go. We can hit the Resume button once the debug has completed, and we can see the wake word application has started. It is waiting for our command, which happens to be ambient. 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 Our project is working. Awesome. We have our wake words collected, compiled, and configured for our custom wake word model. You've now successfully created your own custom wake word using the Ambient Scientific toolchain. If you have any questions, please leave them down in the description below or contact us at Ambient Scientific via our website. Goodbye for now.